All right. Thank you for the introduction, and good morning, everybody. My name is Yousra, and today I'm going to talk about my efforts towards improving user attention towards application permissions. Okay. So as we all know that most of our tasks today are becoming online, and a majority of these tasks are completed using third-party applications. So for example, playing games on Facebook or ordering food online using a mobile app. So these third-party applications are developed by entities other than the owner of the platform using the platform's application programming interface. So third-party applications require access to user information in order to implement certain functionality. And open authorization is an industry standard protocol used to give an application with limited access to users' account on a service. So as part of the authorization flow, a user is presented with this authorization dialog, which lists various permissions that the application is requesting access to. So once the user makes a decision on this authorization dialog, the application is provided with an access token using which they can make API calls to get access to user data. So here's an example of an authorization dialog presented by a Facebook application. And similarly, here's another one presented by an Android application. So because third-party applications are becoming widely available and they're being used daily, so web and mobile platforms that provide these third-party applications are becoming a target of security and privacy attacks. So for example, on Facebook, there are many malicious applications available that request access to more information than is required for their functionality. For example, this most used words app, Most used words app on Facebook creates a word cloud of the most used words by a user using their timeline posts. But if you look at its authorization dialog, it requests access to your current location, your photos, and your education history, which it doesn't really require access to. And this application was shown to be selling user information to third parties. Similarly, there has been a rise in malware attacks on Android applications. So a majority of these malware attacks have been owed to the download of third-party applications. OK, so paying attention to the permissions is actually the first step in assessing the risks involved with a third-party application. So research has shown that users do not pay attention to security communications such as alerts and warnings. So similar is the case with these third-party application authorization dialogues. So one of the reasons behind this is failures in communication delivery. So for example, attention switch and maintenance. So most of these security dialogues fail to capture user attention and maintain it so that they read the permissions listed on these authorization dialogues. So habituation is one of the main reasons behind this. So repeated exposure to the same kind of information on the dialogues makes the users pay less attention to it over time. So studies using fMRI data have shown this. Similarly, there has been studies on Android applications where they've shown that only 17% of users pay attention to these permissions. OK, so in this work, I speculate that looking at permissions is actually the first step towards reading the permissions and then actually understanding them. So we all know that eye tracking devices are becoming readily available and they're becoming affordable. So can we actually use them to make the user pay attention to permissions? So this work has been motivated by several existing mechanisms. For example, there is an approach to get the user into the habit of looking at the URL address bar before they actually enter sensitive information on the website in order to differentiate between legitimate and malicious websites. So once the user looks at the URL address bar, only then the sensitive fields are activated. Similarly, you must have seen many software agreements and policies makes the user scroll down to the bottom of the text before the agree button is actually enabled. So that's where the motivation of our work comes from. So So we propose an I-activated authorization dialog where we actually disable the OK or the allow button on the dialog at first, and then once the user has looked at this permissions area on the dialog, that we the way we do it is by using users' eye gaze information from the eye tracker, and only once the user had actually looked at that area, then we enable the OK button. So we developed a Chrome browser extension for this purpose, which detects the decision buttons on the dialog, and it uses eye gaze information from the eye tracking device in order to determine if there's an overlap between the user's eye gaze coordinates and the coordinates of the permissions on screen. OK, so in order to test if this is effective, we ran two experiments. The first one was to study if it's actually capturing user attention. The second one was to then also see if it's resistant to habituation by repeatedly exposing user to this kind of dialogue. OK, so I'll quickly go over the experiments. So the first experiment was a between subjects experiment that we used to measure the effectiveness of our approach towards attention. So we had three groups. The control group participants was shown the default authorization dialog. Then we had a set of participants who were shown a default authorization dialog with a time constraint of 3 seconds to see if making the user spend more time is equally effective as making the user look at the permissions in order to activate the buttons. So each group of participants were required to use a set of applications that had some eye tracking tasks. There were, for example, games that the user has to play. And then at the end of using these three different applications, the user had to complete an exit survey. And also in the third application, the users were presented with an extra permission to see if the users would look at that permission after they have been shown to other applications. And this permission was the social security number permission, which actually the Facebook does not really require access to, but we were interested in seeing if users would actually notice this kind of permission. And the exit survey was about permission recall. OK, so we had 60 participants, and we gathered these participants from Craigslist. So there were 20 participants per group. Our first metric was permission identification. We were interested in seeing what fraction of the requested permissions the participants would be able to identify correctly. So we had two different permissions. One was the public profile information permission, and the other was the social security number permission. And so we conducted Kruskal-Wallis test to see if there is a significant difference between the three groups, and we did find that there was a significant difference, and we did find that our approach did significantly better as compared to the control group in identifying the social security number permission. So we also calculated the precision and recall of permission identification, and again, we found out that on average, our approach did significantly better. Also compared the eye gaze fixation counts on the three approaches. And of course, since we were actually forcing the users to look at the permissions, our approach had significantly better, more eye gaze fixation counts, but then we were interested in seeing the comparison with the control group with time constraint. And again, we found out there was a significant difference. OK, so the next step was to see if our approach is also resistant to habituation. So habituation is repeated exposure to something, and then seeing if after the habituation period, it's still going to be effective. So again, we had these three participant groups. And the way we habituated the participants was we asked them to answer a set of installation dialogues 30 times. And 20 out of these 30 dialogues were in the habituation period, where we had the same permissions, which was public profile information permission. And then after that, we had this test period, which consisted of additional 10 installation dialogues or windows, where we had this extra social security number permission. So we were interested in seeing that after habituating, would the users notice this social security number permission? And then at the end, we had this permission recall survey to see if users did actually notice the additional permission. So we had 45 participants in this experiment. Again, this was a between subjects study. We had 15 participants in each group. So again, we looked at the fraction of permissions that were identified by participants in each group. and we were mostly interested in seeing the difference between the control and the treatments group, and also whether our eye-activated dialogue group is doing better than the time-constrained group. And again, we did find that there was a significant difference. Also, we calculated the precision and recall. On average, we did find that the users had better precision and recall in both the time-constrained group and the dialogue-activated group, eye-activated group, sorry. So also, we calculated the eye gaze fixation counts for this experiment as well. And we were mainly interested in seeing whether there will be a change in the number of eye gaze fixations from the habituation period to the test period. So we actually looked at just the test period, if there was a significant difference between the eye gaze fixation counts for each of the three groups. So again, if you look at the black line over here, there is a significant difference between the black and the blue line, which is the time-constrained group and the eye-activated dialogue group. Okay, so to conclude, I looked at a design heuristic to enforce user attention on application permissions, specifically through actively using eye tracking. And our conclusion was that it's a promising design heuristic to enforce user attention and also to resist habituation. And we also found out that it was significantly different as compared to the time-constrained group, which was asked to spend a certain amount of time on the dialogue before making the decision. And our future work includes testing our proposed approach on mobile devices. So currently, we only tested it on desktop applications. But in future, we will also test it on mobile applications. With that, I will thank you all, and I'll take questions.
Does the next speaker with me walk come up? So you're in charge of taking questions.
Yes.